What sets us apart from the rest of creation? What is the most distinctive feature of the human mind? Well, a strong case can be made for imagination, the capacity that allows us to detach ourselves from the here and now, recollect the past, anticipate the future, and enter the virtual worlds that are created by novelist or cinematographer or indeed scientist. So I agree with the anthropologist Robin Dunbar that what sets us apart is a life in the mind, the ability to imagine, as wonderfully exemplified by the last talk. Indeed, we spend much of our lives in our thoughts. A vast survey of 250,000 moments of experience showed that people were mind-wandering in almost half of them. Indeed, mind-wandering in every activity more than a third of the time, except making love. The technique of descriptive experience sampling, which probes experience on the wing to try to capture our thoughts as they enter our minds, shows that the most common conscious content is not, in fact, awareness of the here and now, but visual imagery, representation of things in their absence. The Romantic poet, William Blake, was a great proponent of the imagination. He wrote, "All things exist in the human imagination." And indeed, he indulged his own. His wife complained, "I have very little of Mr. Blake's company. He is always in paradise." And I feared once for my research assistant when I looked out of my office window and watched him crossing the busy road outside while listening to music through his headphones and reading the book that lay open in his hands. This feature of our lives, our ingrained tendency to spend so much of our time in our heads, becomes more explicable when we reflect that actually our experience of the here and now also comes from our heads. Let me give you some evidence. So I think you'll agree, or I hope you'll agree, that Misha looks as if she's getting bigger as she crosses the bridge. But in fact, each of those images is the same size. The reason she looks bigger is that your mind is making an unconscious correction for her increasing distance, which we're unable to overcome. That is a size illusion. Here is an ambiguous figure. Take a look at the Necker cube. As you gaze at it, it's quite likely that your perception of depth will reverse. But all that's changed is an interpretation made in your brain. I can assure you that there's no face in this wood. But in the experience of pareidolia, by which we find patterns where none was intended, it certainly looks as if there is. My most vivid experience of the generative nature of vision came as a teenager when I used to sleep in a garden room, and one night I must have left the curtains undrawn. I woke in the early hours, and there was a burglar standing at the foot of my bed wearing a striped shirt. He was palpably real, and I screamed at him. And over the next couple of seconds, he dissolved into a pattern of light and dark cast through a slatted fence. So if those psychological examples don't convince you of the generative nature of our experience, let's think about what happens inside our heads. Here is a neuron. You have about 86,000 millions of these in your brain, organized into intricate networks like these in a set of excitatory neurons in the human neocortex, interlinked by great pathways of connectivity. Now, all these structures are abundantly alive. Deprive them of the flow of oxygen and glucose just for a few seconds, and experience ceases. Our awareness flows from the brain. So it's evidence along these lines, both psychological and neurological, that has led the neuroscientist Anil Seth to say that experience is more inside out than outside in, and the psychologist Chris Frith to describe our experience as a controlled hallucination. So if both our imaginative experience and our experience of the real world come from our heads, how are they related? When we visualize, for example, it turns out that we create a kind of echo of vision in the brain. And the evidence which I'm about to show you comes from functional magnetic resonance imaging. So just to explain, this technique depends on the fact that brain is pretty much like muscle. When you use a region of brain, the blood flow to that region increases, and we can use fMRI to visualize that increase. So you see on this side of the screen what happens in your brain when you are looking at a face, when you're seeing a face. The FG, for example, stands for the fusiform face area, which takes a particularly close interest in faces. If damaged, it becomes very difficult to recognize them. The amygdala and the superior temporal sulcus are involved in reading facial expression. When you imagine a face, here, you activate just the same regions, but more weakly. Visualization is a kind of faint echo of perception in the brain. Here's another example. If you look at a picture of a face and then at a picture of a place, like Big Ben or the Eiffel Tower, you will set up an oscillation of activity in two regions of the brain. The fusiform face area, which I just mentioned, and the parahippocampal place area, which is a neighbor of the fusiform area, which takes a special interest in Big Ben and the Eiffel Tower. But you only have to imagine face and place and face and place to set up just the same kind of oscillation. It turns out that there are big invisible differences in the ability to visualize in this way. So in 2003, about 20 years ago, I met a man, whom we then called MX, though he's since revealed himself to be Jim, who had lost the ability to visualize following a cardiac procedure. And he gave a compelling account of a pervasive change in his experience. So previously, he used to get himself to sleep by visualizing the faces of friends and family, but he could no longer do so. He was an avid reader, and he used to enter a visual world as he read. No longer so. His dreams became avisual. He continued to dream, but without imagery. Previously, if he'd lost his keys, he'd be able to visualize where he'd put them, but he no longer could. It was difficult to fault him on our neuropsychological tests, so in the end, we did a brain imaging study and showed that when he looked at faces, his brain activated quite normally, but when he tried to visualize them, he hypoactivated, failed to activate those regions on the undersurface of the brain, which most of us activate when we visualize faces. So a fascinating case, which we described in a scientific paper, and I wasn't sure that too much more would come of it, but an American science journalist, Carl Zimmer, picked up the story, wrote an article in Discover magazine, and over the course of the next few years, I was contacted gradually by about 21 people who said, we're just like MX, but we always have been. We've always been aware that there's this quirk in our psychological nature. We just don't seem to be able to call images to the eye's mind. I felt that this phenomenon deserved a name, so I chatted with a friend who had knowledge of the classics, and he suggested that we borrow Aristotle's term for the mind's eye, aphantasia, and tag an A on at the end. So that was how the term aphantasia was born, over a cup of tea in a Bloomsbury cafe. Our 21 initial participants told a reasonably consistent story, though with some interesting variations. So most of them noticed this difference in themselves in their teens or 20s, often when reminiscing with friends or families about some previous event they'd shared, and they would realize at a certain point that other people were having a kind of visual experience which they didn't have access to. And characteristically, at that moment, they would realize that when people speak of the mind's eye, they're not being entirely metaphorical. Most of them were more curious than dismayed by this discovery. About a third of them said that this phenomenon didn't just affect vision, it affected all the senses, so they didn't have a mind's ear or a mind's fingertip. More than half of them said they had a rather thin memory for their personal autobiographical past. Very interestingly, most of them dreamt visually. So they knew what imagery was like from their dreams, but they weren't able to conjure it during the day. They had mathematical, analytical, scientific strengths, but then they were all readers of Discover magazine. And we asked them one question which proved to be revealing. We asked them mentally to count the number of windows in their house or apartment. And they could all do this, but they said that they didn't see anything. They consulted a kind of abstract map or schema. Now, words are powerful things, and it turned out that the press liked our new term, so it was picked up. And over the course of the next 10 years, my 21 cases have turned into about 20,000. And I'll introduce you to just a couple of our research participants. So this is Ed Catmull, who is the recently retired president of Pixar Disney. He's a brilliant man. He won the Turing Prize for his discoveries in computer animation. And he realized clearly for the first time that he was aphantasic when a friend tried to introduce him to a meditation technique that opened up with visualizing a sphere. And Ed just couldn't. He fits the bill quite well for aphantasia. He has a rather thin memory for his personal past. He dreams visually, though quite rarely remembers his dreams, and he has clear analytical strengths. His immensely productive career makes the point that visualization is not synonymous with imagination. It's possible to be aphantasic and yet highly creative. Contrast Ed with our hyperphantasic participant, Claire Dudney, whose imagery lies at the opposite extreme. She's sometimes been exasperated by this. Her thoughts have always had a tendency to race off at the least opportunity into a past and a future that she can all too vividly imagine. She told me, "Whenever I'm somewhere, I'm always in the next place." But she draws on her imagery in her work. The Flying Man is a painting drawn from her dream diary. And she's now moving on to work primarily in abstraction, interestingly, to try to convey the sense of raw consciousness that she thinks all of us share. So to recap, we live much of our lives in our heads, detached from the here and now. But even when we're attending to the present, our experience comes from our heads. When we imagine in sensory ways, we reactivate those systems in the brain which we use when we perceive the here and now. But there is wide individual variation in the vividness of imagery. Now, other animals probably have some imaginative experience. It's quite likely that your cat and your dog dream. So what is special about the human imagination that leads us to indulge it so extravagantly? Well, unlike any other creature on Earth, we have evolved to control and share what we imagine. Let me explain what I mean. Here's a graph showing the amazing enlargement of the human brain over the last 3 million years, roughly tripling its size. Body weight didn't change much over this time, so this increase in brain has given rise to a real gain in intellect. What was happening during this time? Well, our ancestors first began to use tools about 3 million years ago. By a million years ago, they'd conquered fire, and cooking followed soon afterwards. So that by the time of the Paleolithic Revolution, 30 to 40,000 years ago, we were already thoroughly cultural creatures. Our culture, that great store of artifacts and traditions that makes us what we are, is the outcome of individual acts of human creativity fueled by our imaginative brains. Brains that evolved in a cultural niche. So we are adapted to culture just as fish are adapted to water and birds to the air. I find this a very exciting, quite radical idea. It challenges the separation of biology from history. It is your biological nature to be imaginative and to share what you imagine. 3 conclusions. First, we live much of our lives in our heads. And as the goings-on in our heads are typically invisible to us, we can be serenely unaware of huge invisible differences between us in our inner lives. From aphantasia at one extreme, affecting about 4% of the population, to hyperphantasia at the other, affecting more like 10%. All our experience involves a creative act, informed by knowledge and skills which we've gathered over a lifetime, and powered by the ceaseless activity of the brain. In imagination, we echo and transform that same activity. We are all imaginative. Imagination is our human birthright. These thoughts were beautifully expressed by the romantic poet Coleridge, poet and critic Samuel Taylor Coleridge, 200 years ago. The primary imagination I hold to be the living power and sole agent of all human perception, and as a repetition in the finite mind of the eternal act of creation in the infinite I am. The secondary I consider as an echo of the former. It dissolves, diffuses, dissipates in order to recreate. It struggles to idealize and unify. It is essentially vital. And thirdly, while our imaginative lives feel like a very personal, private domain, human imagination is in fact profoundly social. We have evolved to share what we imagine. We are deeply cultural creatures. Finally, I hope I've persuaded you that science has some interesting light to shed on imagination. There are reasons for our boundless creativity. Here's a drawing my doodling daughter created years ago. Given what science has taught us about the imagination over the last 50 years, I now agree with Picasso that everything you can imagine is real. Thank you.